Chapter 9, Number 5. Two air track carts move towards one another on an air track. Cart 1 has a mass of 0.28 kilograms and a speed of 0.97 meters per second. Cart 2 has mass of 0.64 kilograms. A. What speed must cart 2 have if the total momentum of the system is to be 0? And B. Since the momentum of the system is 0, does it follow that the kinetic energy of the system is also 0? And C. Verify the answer to part B by calculating the system's kinetic energy. So, for part A, we want the total momentum to be 0. And the total momentum will be the first one times its speed plus the second one times its velocity. And we want this to be 0. So we can solve this over and we get that m2 v2 has to equal m1 v1. Put a different way, object 2 has to have the same magnitude momentum but point in the opposite direction, which is what we have. And so we get v2 is m1 over m2 v1, which is 0.28 kilograms over 0.64 kilograms times the 0.97 meters per second. And this is 0.42 meters per second with two sig figs. Part B says, is it true then that the kinetic energy must be 0 since the momentum is 0? And this is clearly no. Each cart has kinetic energy, and kinetic energy is always greater than 0, so they can't sum to less than 0. The only way you could end up having 0 kinetic energy is if both of them were not moving, but they are clearly moving. Alright, part C says to verify this, so let's actually find the total kinetic energy, which will be 1/2 m1 v1 squared plus 1/2 m2 v2 squared, or 1/2 times 0.28 kilograms times 0.97 meters per second quantity squared, and then 1/2 0.64 kilograms times the 0.42 meters per second quantity squared, 0.19 joules.